All right, this is the next section. We're talking about kites. Again, just like trapezoids, these are quadrilaterals, but they are not parallelograms. Sorry. So the definition of a kite is a quadrilateral with two pairs of consecutive congruent sides. So a parallelogram had opposite sides that are congruent. These are not opposite, they're consecutive. So the sides right next to each other are congruent. These sides right next to are congruent. That is what a kite is. Obviously, as you can imagine, there's a lot of properties that then go with that. So we need to make sure we have those down. So what can we discover about the angles of a kite? So one pair of opposite angles. Oh, guess we're doing those first. Okay, well, I don't know why it's set up that way, but that's okay. We'll go from here. One pair of opposite angles is congruent, and the other pair of opposite angles is bisected. So these opposite angles are congruent, and then these angles are bisected here and bisected here. So the diagonal, that way, bisects both of those angles. So one pair of angles, opposite angles, is congruent. The other ones are bisected. Then over here, one diagonal is bisected. So this diagonal is bisected perfectly. And the diagonals are perpendicular every single time. So again, the hard part of a kite, in my opinion, is that you have to make sure you know there's only one pair of opposite angles that are congruent. You have to make sure you know which one. Only one diagonal is bisected. You have to make sure you remember which one. So in a summary, the kite has two pairs of consecutive congruent sides, no pairs of parallel sides, one pair of opposite angles that are congruent, one pair of opposite angles bisected, and again, that's bisected by the diagonal, and perpendicular diagonals. So this concept summary, this is kind of what we talked about a little bit earlier, a couple lessons ago, where quadrilaterals go into parallelograms, which goes into rectangles and rhombuses and squares. Again, there are parallelograms that don't fall under this, but those aren't the ones we talked about. These are only ones we talked about in this chapter. So the other thing, if it's not a parallelogram, it could be a trapezoid. More specifically, it could be an isosceles trapezoid. And then the other one is kites. Now again, the way you can tell, kites have no parallel sides. Trapezoids have one pair. Parallelograms have two pairs. So mark everything you can on this kite, W, X, Y, Z. So mark everything I can. So right away I know this is a 90-degree angle, and this is the one that's bisected. So these two are congruent. So that's great. I guess we also can say that these two are congruent, and these two are congruent to each other. I know that this angle and this angle are congruent because it's bisected. This angle and this angle is bisected as well. And lastly, I know this big angle, the whole thing, and this whole thing are congruent, those opposite angles. I don't think I'm missing anything, but it wouldn't surprise me if I do. So mark the diagram below with every value that you can find. So if this is 4, I know this one's 4. This is 5, so this has to be 5. This is 12, this is 12. This has got to be 50 degrees. This has got to be 18 degrees. Those are two bisected. And then the other ones you can tell is that this is obviously 90 degrees, and if you want to label all the other ones, you can. Now, I will tell you there's a lot of other things you can find with this. Never mind. I was going to say using Pythagorean theorem, which we'll talk about a little bit later. If you use trigonometry, there's some other things you can find. Oh, and even more basic than that, you could find out what these angles are because this triangle, the angles add up to be 180. So 90 plus 18 plus that angle is 180, so you can find out what that angle is. You can also find the other angle because it's 50, 90, and whatever that has to add up to be 180. So when it says mark the diagram below with every value you can find, technically you can find all those. But I'll go ahead and stop with just the red ones that we found. I guess I don't know exactly where they want you to stop with that question. So find the value of all the variables in the kites below. So this one is x is equal to 10. It should be an easy one. Y is equal to 6. So a little warm-up problem a little bit. This next one, so the diagonals are 90-degree angles. That's 6x plus 6 is 90 degrees. So subtract 6 from both sides. 90 minus 6 is 84. Divide both sides by 6 is 14. Angle A for this one should be a good one. That's just 90 degrees because, again, the diagonals are perpendicular. And this is where, again, to find angle B, so if A is 90 degrees, this one also is 90. So 40 plus that 90 plus B has to add up to be 180 because that is a triangle. That's one of the things you have to remember what we learned before. So 130 plus B is equal to 180. Subtract 130. B is 50. So let's see here. Okay, so this one's a little bit of a unique one. So I know this is 125, so this has to be 125. Now, I think the easiest way to do this one is to realize that it's still a quadrilateral. And what did we learn about quadrilaterals like the very second lesson or first lesson? All the angles inside add up to be 360 degrees. So 125 plus 125 plus x plus 30 plus x adds up to be 360. I think I said 360 earlier. If I didn't, that's what I meant. So combine your like terms, 125, 125, and 30 is 280, plus x and x is 2x. Is 80. Divide both sides by 2, x is equal to 40. So again, that's another one that we didn't really use a trapezoid formula, but you have to make sure, and that's where this stuff gets confusing, is remembering everything that we've learned so far. There's a lot of little things that come into play. And I will give you a heads up and be nice that I'm not going to throw any trigonometry in here because that's another thing we could do. You might have one like this, use the properties of the kites and the Pythagorean theorem to find the value of x. So this is 7, this is 9. So 7 squared plus 9 squared, that's 90-degree angle, is equal to x squared. 49 plus 81 is equal to x squared. 130 is equal to x squared. And take the square to both sides. Again, this is just Pythagorean theorem. Don't make this harder than it is. I ended up getting my x is 11.4. Then same thing with this triangle up here. I know that's 40. And this up here is also 9 because this one was 9. So 9 squared plus 40 squared is equal to y squared. That's 81 plus, what, 1600 question mark? Yeah. 1600 is equal to y squared. That's 1681 is equal to y squared. And the usual now, take the square root. You end up getting your y is 41. Now again, I'm imagining that if you actually have to use a Pythagorean theorem, it's probably going to be like this one where it tells you to use a Pythagorean theorem. I will try to look into that. I will say don't hold me to that just in case, but I would assume that it will. And again, if I can notice it, I'll hopefully help you out with that before we take the test. So if you have any other questions, make sure you're contacting me. If you need anything, most definitely let me know.